Hey guys, and welcome back for another lesson on surds. I hope you joined us for our introductory lesson where we simplified surd terms, and our second lesson where we simplified surd expressions by grouping like surd terms, that's by adding and subtracting, and our third lesson where we multiplied and divided surd terms. If you missed those lessons, I'll link them down in the description box for you below, because you'll need all three of those skills to be able to expand surd brackets today. If you've already seen those lessons, let's get started. Let's just start by going through the rules of surds that you should already know. You should already be able to add and subtract like surd terms. Like these, I would consider like surd terms because we've got the same number underneath the square root sign. So if I've got a root b plus c root b, I can simply add together the coefficients, or the numbers in front of the irrational parts. So that's a plus c root b. I could also multiply irrational expressions, where they're square root expressions, by simply multiplying the values under the square root sign. So I could group root a times root b together to simply be a times b underneath a square root sign, so root ab. We've seen this before when we were simplifying surd terms, although we did this a bit backwards. You might think that you can't simplify square root 18 because it's not a square number. However, we can split 18 into a product of its factors, where one of those factors is a square number. 18 is the same thing as 9 times 2, so the square root of 18 is the same as the square root of 9 times 2, which we split off to the square root of 9 times the square root of 2. And as I said before, 9 can be square rooted because it's a square number. The square root of 9 is 3. 2 cannot be square rooted because it's a prime number, it's not a square number, so it stays underneath the square root sign and remains our irrational part. So root 18 simplifies to 3 root 2. We can also square irrational expressions where we're talking about square roots, and you should know that that rationalizes them. For example, if I do square root a multiplied by square root a, multiplying a value by itself gives you that value squared. So that's the square root of a squared. Since squaring and square rooting are opposite operations, if I square something that's being square rooted, those operations cancel each other out, and I'm left with just a. We can also multiply surd expressions together with both rational and irrational parts. I can do a root b times c root d, even though they're not like surd terms. I don't have to have the same numbers underneath the square root signs. I simply multiply the rational parts together, so a times c, and then I multiply the irrational parts together, so root b times root d. So that gives me ac times root bd. Then finally, we had a look at surd divisions, or fractions. We learned that the square root of a fraction a over b can be split off into the square root of the numerator over the square root of the denominator, so root a over root b. If you have not yet copied down these rules, hit pause and take a minute to do that now before we go on. You should already be able to expand algebraic brackets. If you're not yet familiar with expanding brackets or quadratics or dots, you may want to check out some of the videos I'm linking down in the description box for you before we move on. Assuming you know how to expand algebraic brackets, this shouldn't be too much more of a stretch for you. Let's just treat the irrational values like the square root of 5 as we would treat algebraic variables like x. So if I'm multiplying this out, I'll draw my loops, or follow the rainbow as I like to say. We'll do the first term of the first bracket multiplied by the first term of the second bracket. So 2 times 3, which is 6. Then I'll do 2 times the second term in the second bracket, so 2 times root 5. Now, since 2 is a rational number and root 5 is an irrational number, I can't really multiply them together, so I simply write the 2 in front of the root 5. So plus 2 root 5. Next, I'll do root 5 times 3. Again, I'll put my rational number out front, so I'll write that as 3 root 5. And finally, I'm doing root 5 times root 5. I'm squaring my irrational number. Root 5 times root 5 becomes root 5 squared. The main difference between multiplying variables together and multiplying irrational values together is that when we square an irrational value, it becomes rational. As we just saw, the square root of 5 squared becomes 5. So when I simplify this expression, first I'll group my like terms together. 2 root 5 plus 3 root 5. I've got the same number underneath the square root sign. So I can just add the 2 and the 3 together, making that 5 root 5. So that's 6 plus 5 root 5 plus 5. Now I can group together my rational terms. That's my 6 and my positive 5. 6 plus 5 is 11. So it's 11 plus 5 root 5. Always double check that your irrational part is simplified as much as possible. Now the 5 I have underneath that square root sign is a prime number, so I can't split it off into factors where one of them is a square number. I can't rationalize that any further, so that's my simplified answer, 11 plus 5 root 5. Here's another example. It's a slightly more challenging one because I've got 2 irrational values inside each of these brackets, and each of those irrational terms involve a rational and irrational part. But this shouldn't be too difficult for you because you've already worked with algebraic terms, which consist of both numbers and variables. For example, 3x or 2y. We can just treat 3 root 2 as if it were 3x, and 2 root 7 as if it were 2y. They're both surd terms with some value underneath the square root sign, and they don't need to be the same number under the square root sign for us to be able to multiply them. So again, let's follow the rainbow. 3 root 2 times 2 root 2. Rational times rational, 3 times 2 is 6. And irrational times irrational, root 2 times root 2 will be root 2 squared. Next, 3 root 2 times 3 root 7. Rational times rational, 3 times 3 is 9. And irrational times irrational, root 2 times root 7 is root 14. So plus 6 root 14. Next, we're doing 2 root 7 times 2 root 2. Rational times rational, 2 times 2 gives me 4. And irrational times irrational, root 7 times root 2 gives me root 14. So plus 4 root 14. Finally, I'm doing 2 root 7 times 3 root 7. Rational times rational, 2 times 3 is 6. And irrational times irrational, root 7 times itself, root 7, is root 7 squared. So plus 6 root 7 squared. Again, we simplify. Our irrational values, which are being squared, become rational. So root 2 squared becomes 2, and root 7 squared becomes 7. And my 2 like terms in the middle, 6 root 14 plus 4 root 14, can be grouped together to make 6 plus 4 is 10, so 10 root 14. So I've got 6 times 2 plus 10 root 14 plus 6 times 7. Let's simplify that a bit further. My rational numbers become 6 times 2 is 12, and 6 times 7 is 42. And I can group my rational numbers together. 12 plus 42 is 54. So I've got 54 plus 10 root 14. Double checking that my irrational value there cannot be rationalized any further. 14 has only got factors 1, 14, 2, and 7. And none of those are square numbers that would help me to rationalize this value. So that's my simplified answer, 54 plus 10 root 14. Going on to squaring brackets, which you should have also seen when we were working with quadratics. You should know that when you need to square a bracket for any type of expression, surds or otherwise, you should always write that bracket out twice. So I'll do 3 minus root 3 times 3 minus root 3. That's going to make sure that I follow the rainbow and I multiply each of these terms together correctly, not just squaring the first term and squaring the last term. Also notice that I put these minus signs in green. Be particularly careful with your plus or minus signs, especially if you ever see a minus sign in any type of expression or equation. So we're going to be very careful with our signs when we multiply this out. I'm doing positive 3 times positive 3. That gives me positive 9. Next, I'm doing positive 3 times negative root 3. So that's going to be a negative term. And as this is a rational value times an irrational value, I just put the rational value out front. So that's going to be negative 3 root 3. Next, I'm on to negative root 3 times positive 3. A negative times a positive becomes negative. And again, I put my rational value in front of my irrational value. So that's negative 3 root 3 again. Finally, I'm doing negative root 3 times negative root 3, positive root 3 squared. Negative times negative gives us positive. Simplifying that, we know that root 3 squared becomes rational. So that becomes 3. And negative 3 root 3 minus 3 root 3, be very careful here. If you start with a negative value and you subtract from that negative value, it doesn't become positive, it becomes more negative. So that's negative 6 root 3. So I've got 9 minus 6 root 3 plus 3. I've got two rational terms here which I can group together. 9 plus 3 is 12. So I've got 12 minus 6 root 3. And double checking that my irrational part cannot be rationalized any more than it already is. The 3 that's under the square root sign is a prime number, so it can't be simplified. Our final answer is 12 minus 6 root 3. Next, remember dots? Hopefully you noticed something special about these brackets. We're about to find out what it is. As usual, let's multiply the first term by the first term. So 4 root 2 times 4 root 2. Rational times rational, 4 times 4 gives us 16. And irrational times irrational, root 2 times root 2 gives us root 2 squared. Next, we'll do 4 root 2 multiplied by the second term in the second bracket. So rational times rational, 4 is the only rational value, so plus 4. And the irrational times irrational, root 2 times root 5 gives me root 10, so plus 4 root 10. Next, we're on to the second term of the first bracket, and be careful because it's negative. This is negative root 5 times 4 root 2. Rational times rational, that just gives me negative 4. And irrational times irrational, that's root 5 times root 2, which is root 10, so negative 4 root 10. Finally, the last term of the first bracket times the last term of the second bracket. Be careful again, we've got a negative sign here. Negative root 5 times positive root 5. A negative times a positive will give me a negative. And root 5 times root 5 is root 5 squared, so minus root 5 squared. Notice that when I want to simplify this, the middle two terms are our like terms, but they're exactly the same terms, but with opposite signs. So when I do 4 root 10 minus 4 root 10, they cancel out and become 0. So I end up with 16 times 2, because the root 2 squared became rational, plus nothing in the middle here. I could have left that blank, but I've put 0 there to see that it's gone. Minus 5. Now that there is classic dots. Dots is the difference of two squares, where the middle term gets cancelled out because of the opposite signs of the same term values. The positive 4 root 10 and the negative 4 root 10. And that's what happens when we multiply brackets together, where we've got the same terms in each bracket, but the opposite signs between those terms. So let's go on to simplify this. This is going to be 6 times 2, which is 32, minus 5, which simplifies to be simply 27. As I said before, dots for surd brackets are the same terms in each bracket with the opposite sign between them. This eliminates the irrational term, leaving a rational single term as our simplified answer. So I've just got 27, a rational number, as my answer. You may need a minute now to think about that, so hit pause, copy out these examples and copy down these notes, and hit play when you're ready to go on to the practice exercise. On to our practice exercise now. I need you to hit pause, copy these questions, expand the bracket, so follow the rainbow, and simplify your answers as much as possible. Before you start, maybe you want to have a careful look through these examples and see if you can identify any examples which would produce dots, a difference of two squares, which of course means the first term squared minus the last term squared, which would give you a rational number minus another rational number, which will give you a single rational numbered answer. Remember, dots are the result of multiplying two brackets together which contain the same terms with the opposite plus or minus sign in between them. Did you see the dots? Go ahead and hit pause now and give that a go, and hit play when you're ready to take up the answers. I hope you had a chance to hit pause, because here come your answers. For question 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, 10, was that a dots? It gave me a single term, and it's a rational term. 11, was that a dots as well? It doesn't look like a dots. However, notice that there's a common factor here. I could divide both terms by 2, and that would simply be 2 times root 7 plus 6. Root 7 plus 6 are the same terms as in the second bracket, but the second bracket's got a minus in front of the 6. So that would have been 2 times the dots. In fact, it's 2 times the dots we have above. It's twice negative 29, negative 58. I bet you didn't spot that one. And question 12, I hope you wrote this bracket out twice to do this. It's not just root 7 squared minus 36. How'd you do? Hopefully you did well, and I hope you found this lesson helpful and interesting. Please let me know if you had any problems down in the comment section. Otherwise, great job, keep it up, and I'll see you soon.